3 words. Will people matter? Isn't that what everyone's thinking about right now? We are in a crisis of confidence of human ingenuity. It's not a collapse in the belief that AI will matter. It's a collapse in the belief that people will matter. And just like us, you're thinking about it as you get ready for work in the morning. You're thinking about it when you drive home. And you're thinking about it when you're having dinner with your kids. So let me pose a question to you. Do you have the courage to stare down this moment and build the future you want for them? Because no one knows your business better than you. And the way you show up right now with AI will determine your brand value to the next generation. But I want to be clear, it's not about choosing between people and profit. After all, SAS is a great example of how you can invest in employees while remaining profitable for 50 years. It means building a bridge to the next generation of people, empowering them with AI so they can solve what was previously unsolvable. But we also have to ask, why do we even need AI? Well, we know that organizations are creating exponentially more data every day with no end in sight. This is the information landscape. However, it can really be overwhelming for the workforce to consume and make sense of this information. The difference in growth rates leads to the information overload that fuels confusion, fatigue, and opportunity. So the question becomes, how do we close this information gap? Well, the answer has always been we empower people with technology to scale human observation and decision-making. Since the beginning, SAS has been pioneering technology breakthroughs to help you close the information gap, gain a competitive advantage. Let's look back at the history of the last 50 years of all the innovation we've done. It all started with the SAS programming language. It was the first capability we built to turn data into decisions. And then from there, as computing became more pervasive, we created a multi-vendor architecture to make sure SAS could run anywhere you needed it to. And then we built out these incredible industry solutions as people worked more and more with analytics in their respective industries. It helped them scale domain knowledge and get faster time to value. Then we were way ahead in building out capabilities for machine learning, which set the foundation for capabilities in deep learning. Then as the cloud matured, we built a multi-cloud architecture to ensure our software could run on any cloud of choice, inclusive of your on-prem environments. And recently, we developed a synthetic data generator to build differentiated models when real data is limited or doesn't exist at all. For 50 years, we have been in the relentless pursuit of technological breakthroughs to give you the power to know. And that brings us to this moment with AI. For the first time, AI has the potential to bend the curve and close the information gap. But this requires you to trust the results. Specifically, it requires you to trust the results from agentic AI. Now let's talk about this. Every agentic AI workflow can be comprised of both deterministic and non-deterministic elements. A deterministic approach follows a fixed path of predefined rules and logic. Given the same input, it produces the same output every time. Let's go through an example. Let's say you're a loan underwriter who's automating a credit policy. The person's income is greater than $80,000. Their debt-to-loan ratio or debt-to-income ratio is less than 35%, and their credit score is greater than 720. That loan is approved every time. Every applicant that has the same criteria is approved every time. Now, let's compare that to a non-deterministic approach that follows an adaptive path using large language models, but it can produce different outcomes from the same input. It's sensitive to the context it is given. For example, think of a financial crimes team that is prioritizing anti-money laundering alerts with AI. The agent analyzes income and to include things like customer profiles, transaction descriptions, previous cases, and investigator notes. The large language model-based agent produces a recommended disposition and explanation. But because the large language model is probabilistic, with no fixed rules or logic, 3 different runs can produce 3 different outputs. It might recommend that it's a low-risk alert, or it might set it as a high-risk alert, or because of subtlety in the context, it might recommend we actually close the alert. There's not enough risk even to be concerned about. If the team is working on incorrectly prioritized alerts, the bank is exposed to increased risk. And to overcome this, you must add guardrails to ensure accuracy and prevent compound error at scale. Another part about agentic AI I want you to know about is how trust shifts. Determinism and non-determinism can be in agentic AIs, but the way they manifest in individual and enterprise use cases is different. And as a result, trust can't be scaled the same way. For individual use, the goal of agentic AI is typically like things like coding, research, analysis, and brainstorming. But when non-deterministic LLMs are present, the human must look for errors and really course correct as needed. That means, though, the trust ultimately sits with the individual. Now, when you move to the enterprise, agentic AI is all about breaking down data and organizational silos to automate business workflows. Therefore, trust shifts from the individual to the accuracy and repeatability of the process itself. However, because non-deterministic large language models are there, you must integrate into the agentic AI workflow guardrails to ensure accuracy and prevent compound error at scale. Now, to get more into the details of this, I want to illustrate how this is being done in AI-assisted software development. And this is exactly what SAS is doing right now inside our organization. We break this down into 4 phases: design, execute, verify, and validate. Let's start with the design phase. In the design phase, human value shifts from typically writing code to the new discipline of context engineering. This requires strong domain expertise to define the functional experience, the test objectives, and overall the technical requirements. Second, AI agents can develop test suites to automatically verify and validate. Now, let me kind of define these very important phases. First, verification confirms that the software meets the technical specifications of the design. And validation really makes sure that the software meets the business objectives of the organization. The verification and validation phases are absolutely critical for guardrails to ensure accuracy and to make sure we have repeatability of AI-generated code. Finally, the agent uses the context from the design specs and the testing suites to generate code, and the entire human-in-the-loop process iterates until the verification and validation phases pass. That's how it works, folks. But guess what? You can apply this same approach to industry use cases. And I want to start with an example in life sciences. Imagine a clinical trial for a new cancer therapy. Behind that trial is a protocol that defines really why the trial is being conducted, what will be tested, who can participate, and how will the study be conducted to ensure regulatory requirements are met. Everyone in the industry knows that AI provides a huge opportunity to improve the efficiency and accuracy of clinical trials. Let's apply this repeatable blueprint with AI. First, in the design phase, we leverage AI to read documents with protocols and operating procedures and data. AI agents then parse those documents, extract requirements, and map them to regulatory standards. Digitizing the protocol alone improves the ability to match the right patients with the right therapies. All of this results in better context engineering that drives the execution phase of the remaining things we have to work on. In the execution phase, raw clinical data is arriving into the organization, and there's a massive amount of this data, and it's being transformed into regulatory standards. Double programming analyzes the trial data to produce statistical results. This is achieved by combining human and AI programming that derives the same data with automated comparisons to find any discrepancies. The result is a faster and more consistent execution without compromising regulatory compliance. From there, agents work in parallel to check protocol adherence, CDISC compliance, data quality, and security. This verification testing is completed in hours versus weeks. Finally, AI compiles the clinical submission report and validates for accuracy and completeness. And the result is a clinical trial submission that runs in weeks rather than months. Now, imagine what could happen without the verification and validation phases. A protocol requirement is misinterpreted, or a submission looks complete, but regulators find some inconsistencies. The clinical trial comes to a halt. Data has to be reanalyzed, patients wait longer, costs increase, and trust erodes. In clinical trials, verification and validation aren't just technical details. They are the difference between getting a therapy to market or it being delayed when patients can't afford to wait. And I have to say that SAS is delivering these agentic AI outcomes today that help companies get life-saving drugs to market faster. But you might ask, what makes our approach with agentic AI unique? Well, for us, it comes down to intelligent decisioning on SAS Viya. It can automate any business problem on any cloud with unparalleled governance. You can carefully design sophisticated and directed, controlled agentic workflows. Those workflows then can deploy a set of intelligent agents. Some of those agents can orchestrate the entire workflow, and other agents are there to validate and verify answers. And the result are trusted business outcomes. With intelligent decisioning, we uniquely give you the right balance of control, creativity, and governance to build trusted agentic AI workflows. Now, a lot of companies talk about agentic AI in a silo, but the reality is it's just one capability in the enterprise. What do I mean by that? Well, a lot of the technologies we talk about are starting to converge, and they're creating even larger business opportunities for your organizations. For example, machine learning predicts outcomes. Generative AI helps us investigate, reason, and explain. Agentic AI allows systems to plan and act and execute across complex workflows. Computer vision creates new signals to detect patterns. And synthetic data safely explores scenarios that are either rare, risky, or haven't even happened yet. And optimization chooses the best outcome from everything above. And when these capabilities come together, you don't just get better models, you get a digital twin. A living replica of everything you can build for your organization to optimize your business. And last year, we partnered with Epic Games and Georgia Pacific to create photorealistic digital twins. and we blew people's minds. Our first project was to simulate Georgia Pacific's manufacturing facility and optimize vehicle sizes and routes. The digital twin sparked the imagination of businesses worldwide. We are actively scaling the art of the possible across every industry. Which brings us to our current work that we're doing right now with Sterilcentral. They are the largest medical sterilization provider in Denmark. I want you to picture a hospital operating room. The surgical team is assembled and ready. The patient is already under anesthesia. Maybe it's your wife undergoing a C-section, or maybe it's your father scheduled for heart bypass. The procedure is about to start, but something is wrong. Some medical instruments are missing, and others are contaminated. The entire surgery grinds to a halt, not because of a skill or knowledge, but because miles away, a sterilization process broke down. This is the part of healthcare that most people never see, but it's the part where everything begins. Sterilcentral's goal is to make sure this terrifying moment never happens in the operating room. They are the invisible backbone of surgical care, ensuring that every scalpel, clamp, and instrument is sterile and safe. But here's the challenge. Sterilization centers are incredibly complex ecosystems. Tools move through dozens of steps like washing, drying, packaging, and shipping. That means thousands of instruments, hundreds of cycles every single day. And Sterilcentral knew that every bottleneck or delay could have significant impacts to hospital operations, or even worse, to human lives. To avoid that risk, they needed a better way to see, understand, and optimize their entire workflow and operations. So they came to SAS. Together, we built an amazing digital twin of their Copenhagen facility, a living ecosystem of every room, machine, and workflow. And as you can see, the visuals are stunning. But the twin also gives Sterilcentral the ability to explore and test any scenario they can imagine, and it's already sparking ideas around innovation and improvement. Let me share two examples. First, we ran a scenario-based optimizations across their entire workflow, and Sterilcentral noticed that medical trays were getting stuck in what's called a buffer lift, which lines up the trays for cleaning. This created a bottleneck in the whole system. But the digital twin found that the real slowdowns were further downstream in the process. The lift just looked constrained because it's in the central distribution point of the whole flow. And that insight changed everything. So we recommended targeted adjustments, which resolved the bottleneck and improved operations. But then with the same digital twin, because of how incredibly high fidelity the graphics are, we were able to train a computer vision model that checks if workers are wearing the protective gear. Look at the detail on the gown. We call this new approach synthetic vision because the model is trained entirely on synthetic data created with the digital twin. If a worker puts a glove or mask on incorrectly, they can accidentally contaminate the clean tools. The left side's the real facility, the right side is the digital twin. You can't tell the difference. That's how good our digital twin is, and that's how incredible our computer vision models are. Now, all of these improvements ultimately mean that doctors get the tools they need, surgeries start on time, and patients get the care that they expect. For SAS, it's not about just helping our customers, it's helping our customers help their customers. And if Sterilcentral can reinvent its operations with the digital twin, imagine what you can do in your organization to improve your operations. Now, you've seen how both manufacturing and healthcare companies can benefit from digital twins, but that's only the beginning. In energy and power, we are training drones with computer vision to spot power line failures before they happen. What does that mean? That means we can prevent power outages and stop wildfires. In oil and gas, We are creating digital replicas of deep sea rigs to detect unsafe conditions like gas leaks. That means we can keep workers safe and prevent expensive repairs. The digital twin becomes the ultimate proving ground for your what-if questions and gives your business a decision advantage. And we are scaling this impact across every industry in which we operate in. Now, I would love to talk more about this on main stage, but we can continue the conversation at the Spotlight stage in the Innovation Hub. So please check this out. Now, everything I just talked about today is powered by our comprehensive portfolio, SAS Viya. Our platform provides every capability that customers need to innovate and create intelligence that allows them to have a competitive advantage. Our solutions integrate trusted domain expertise and domain intelligence directly into your customer workflows. And whether you need applications, agents, or models, SAS Viya delivers a consistent decision advantage. However, we know the pace of change and complexity of today's world demands a new capability: digital twins. As you continue to navigate disruption, our digital twins empower you to simulate, understand, and move first. And finally, our governance software ensures trusted and transparent outcomes across the entire enterprise. And over the next 2 days, you'll see SAS Viya deliver on every one of these problems at scale and in the real world. Now, let me close by coming back to where we started. Will people matter? Of course we will. In fact, we have never been more important than we are right now. From the very beginning, human ingenuity has been the engine behind every breakthrough that has changed the world. It starts with the printing press, with scaled knowledge. Transportation, scaled movement. The mobile phone, scaled connectivity. The internet, scaled information and commerce. The cloud, scaled data and computation. And social media, scaled influence. And now, AI will scale human observation and decision-making. There's no question that this is a pivotal moment, but it's just a moment. And we can't afford to stop here. Why? Because the biggest problems are still in front of us. We still need to find cures for cancer, Alzheimer's, and heart disease. We still need to stabilize our climate and our oceans. We still need to improve access to housing and healthcare, and we still need to stop fraud. The problems and the list of these problems are endless. But we won't solve these problems by having small-minded, misguided debates about AI and the role of humans. We have to think bigger. And there is a name for this kind of shift in perspective. It's called the overview effect. In 1987, Frank White coined this phrase to describe how astronauts feel when they travel to space and they look back at Earth. And in 2026, Artemis II brought this entire effect back to life. Astronaut Victor Garber said, "We want everybody to be a part of this mission." So let's join them. Let's start here at the Gaylord Hotel and travel out to space. From this distance, something profound happens. We don't see borders. We don't see religions. We don't see political lines. We see one planet and one shared humanity. That is the perspective we need to have in this moment with AI. Because every breakthrough technology follows the same arc. It solves a problem, it reshapes society, and eventually, it fades into the background of everyday life. Yesterday, it was the internet, and today, it's AI. And tomorrow, I can assure you, it will be something else. But the only thing that outlasts every innovation is people. Thank you.